tell the limit whether they're coming from the left or the right. So the big thing to remember is if you have something like this that says x approaches some number, come on. I know it's Monday and all, but you should be working. You're off all weekend. If it has like this, limit as x approaches some number, and that number they have this comes this way to get to that limit. If it's this, it goes this way to get to that number. So it comes from the negative or it comes from the positive. And I already have to undo my screen. If you don't have that, it means it comes from both sides. So if it comes from both sides, a limit might not exist if it goes to two different locations. So a directional limit should be able to exist, meaning if it comes from the right or comes from the left. If you don't know which way it came, then it goes a little differently. So let's take a look at problem number 2. Problem number 2 on that page. It says the limit as x approaches negative 35, and then you have 35 plus x. So what you're going to do on that one, if you have the limit as x approaches negative 35, and then you have 34 plus x, this is just a direct substitution. It's a linear situation. Plug negative 35 in for x, so you get 34 plus negative 35. So that's just negative 1. And then things that you can do with that type of problem is you can just jump on Desmos. It's not going to do the limit, but you could easily say y equals 34 plus x. And then you could say as x goes to negative 35. So let's take that home. Let's find our graph first. All right. So if you wanted to figure out on a direct substitution what the limit is rather than even plug it in, you can just go y equals negative 35, come down here, and, well, yeah, 34 plus negative 35 is indeed negative 1. So that's the limit. That's a direct substitution. But if you look at the next one, you have a fraction. So the problem with the fraction is if I plug 3 into that denominator as it sits right now, I'm going to get an undefined term. But we're going to see how close we can get to that undefined term. Oops, I want to go back there. So I'm going to go y equals fraction so we're going to go x squared minus 9 on top and x minus 3 on the bottom. Okay. So again, it looks something like that. What we have to do is if we wanted to figure out what the limit as x approaches 3 would be, I'm going to go x equals 3. And notice if I get to right here, I get 3 comma 6, which is great. Let's go on the purple line. Oh, I can't even get to my purple. So let's undo that. Let's go to 3. I keep seeing an undefined that's there, but I can't get to it. So that's undefined right there. Agree? Okay, so does the limit exist at that? I mean, that undefined term is a 0, or is a hole right there. And my limit's coming from both this way, so I'm coming down this way, and I'm coming this way. So does the limit exist? Could a hole be a limit? The answer is yeah. I mean, if I come down this line like this, if you follow my pen, and I'm coming up this way following my pen, am I going to get to the exact same hole? So again, what that means is, let's bring that down, make that fatter. All right, so as I'm doing this, here's like 3 down here. If I come both ways like this, am I getting to the same hole? If I come down, hole. If I come up, hole. And again, we could sit there and zoom in on that hole all day long and see what it actually looks like. And how you know you're looking at a hole is as I keep trying to zoom in at that 3, it won't show us a hole necessarily, but it's going to start getting weird looking as I get really close to it. There it is. There is this place of uncertainty. Okay? I don't know if that's actually what a hole looks like, but I know that because it's an undefined term, Desmos is going a little crazy with it. So it's like, does this graph actually do this and come straight up? And does it come up this way and go straight down? The answer is no. It's like, I'm trying to get here, but we have a hole. It's undefined. So Desmos won't show us a hole, but those aren't necessarily, that's not a vertical asymptote where you have some sort of weird function that you've graphed. But just be aware of things that go in. So sometimes you can try and plug it in, and then sometimes a rule might be something like this, where it would be, I'll go here. So if I go and looked at number 3 a little bit more extensively, as the limit as x approaches 3 of x squared minus 9 over x minus 3, you might want to realize I can factor the top to x plus 3x minus 3. Thank you, Algebra 1. Okay? We're on limits 4.1. We had worked on it the other day. And then on bottom we have x divided by that. Those cancel out. So what is the limit as x approaches 3? And it's basically what's going to make that 0. So our answer is 3, because on Desmos, if we come both ways, it gets to that. A limit is something I'm approaching, I'm not getting to. So I get really close to that weird looking graph. And again, if you zoom out on that graph, you can't really see the hole any longer. It just doesn't exist. It doesn't appear that it exists. So Desmos, maybe some point, will actually make a hole that takes place there. All right. Then the limit as x approaches 7, we'll just factor those out. And then we have 2 different limits at there. And then go down to number 7. They have the total revenue for a product by x equals 1600 minus x squared, or 1600x minus x squared, where x is the total number of units sold. Determine the limit as x approaches 100. So that can be a direct substitution in there. You're not going to get, just plug 100 in for your x and your x squared and multiply, make sure you multiply your x by 1600 and subtract your situation from that. 8 and 9. Ooh, let's talk about when a limit goes to infinity. Okay, so if we had a limit as something goes to infinity, or a limit as something goes to negative infinity, so this is like the end behavior. Okay, sometimes this is thought about as a slant asymptote. The slant asymptote is as I go way far in the x direction to the right, or I go way far in the x direction to the left, where is it going in the y direction? Okay, so those are a few things to kind of look at that. What's hard about like 9, 10, 11, if you look at number 9 on that back page, we have a limit as x goes to positive infinity. Oh, x plus 1. All right, so what happens to this fraction Does this fraction become a bigger fraction or a really small fraction if I plug really big positive numbers in? So like 3 over 1, or if I plug 1 in, I'd get 3 over 2. If I plug 2 in, I get 3 over 3. If I plug 4 in, I get 3 over 4. Like, if I plug 20 in, I get 3 over 21. If I plug 100 in, I get 3 over 101. If I plug 10,000 in, I get 3 over 10,001. What's happening to this fraction? Is it becoming a big fraction, or is it becoming like itsy bitsy? Itsy bitsy. Okay, this isn't saying I'm coming from any direction on infinity. Infinity won't have a direction at the very, going left or right, because infinity is way out to the right or way out to the left, depending on its positive or negative direction. So, what if I keep making this fraction smaller and smaller and smaller and smaller? What number do I eventually approach very closely? What do you think? So let's look at Desmos, see if Desmos could be more helpful. So if I get rid of those, let's go y equals 3 over x plus 1. And I can't see my graph, so let's go home. Okay. So as I go to negative infinity, I'm going out this way to the right. What horizontal line am I getting really close to if I keep going further and further? If I go farther out this way? Do you think it's ever going to cross the x-axis, or do you think it's going to get really close to the x-axis? So I can get to like right here. Notice as I'm coming across, it's getting small. Let's get way out here to 5,000. 0.01. It's getting small. Let's go even further. Let's go to 22,000. It appears that it's at 0. Is it really at 0, though? Is it going to cross that x-axis? Is it ever going to touch it? The hard thing is, Desmos, that 0 that's in the y portion is a really tiny decimal. It's probably, well, if we just did this, 3 divided by 21,501, that's a really tiny little decimal. Okay? If I go out even further, let's take this out. I don't even know how far decimals will go out before it says, what are you doing, dude? All right, 130 million. How's that? So that means my denominator, oops, so down here. Can't even do it. There we go. 130,001. Look at that decimal. It's even smaller. I mean, we're 1.3 million out. So what do you think that number is getting close to? Is it getting close to 10? Is it getting close to a billion? Is it close to infinity? 0? What do you think? I don't know. So the answer is, if your fraction's denominator is growing larger, your fraction is becoming a smaller fraction, which means you are approaching, in this case, 0. Okay, so the limit on number 9, as we go to infinity, is 0. And you just have to take it back and look at what the graph's doing. That graph is, as I go to the direction in the right, my y direction is getting closer and closer and closer to 0. So my limit for number 9 is 0. But if you looked at number 10, and you change that up a little bit, and you just said y is equal to x to the third. Oops, hang on. Let's make it a fraction first. X to the third minus 1 over x to the third minus 4. plus 4, excuse me. All right. Ooh, look at that weird little bobble in there. I don't know if that's a wiggle. I'm not quite sure what that is, but that looks kind of funky. I think it has to do with that you could factor out the top being x minus 1, x squared, minus 1x plus 1, I guess. But as that one is going out far to the right, what number do you feel I'm coming close to? I mean, if this number is 5, this is 1, 2, 3, 4, 5. As I go out this way, what number do I appear to be getting close to in the y direction? What do you think? It's not 0. It's not 5. Anybody? Is anyone awake still? Not really. We're approaching 1. So basically, I can use Desmos to help me figure out what the limits would be. If I wanted to do the same limit saying it's going to negative infinity is also, if I go to the left, I continue out that way forever towards the gym area. I mean, that's way far out. It's going to approach 1 as well. So when I'm going out to the infinities, take a look at stuff. Now, a big way to kind of convey what's going on with this is if I looked at number 10 and I had this, we can go back to our algebra 2. If the polynomial on top can be written over the polynomial on bottom, the degree on top and the degree on bottom are equal. You take the lead coefficient, so y equals 1 becomes the end behavior asymptote. The end behavior asymptote becomes the limit as I approach infinity, or negative infinity. Okay? But as we get to number 11, what do you think just by looking at it? Degree on top and the degree on bottom are the exact same. Agree? So it's 5x to the third minus 4x, and 2x to the third minus 2. I go to my highest degree. They're the same. I take whatever that is, so I'm going to get y equals 5 over 2, or in this case, it's going to be 2.5 as I go out to negative infinity. If I went out to infinity, it'd be the same thing. It's the end behavior that's taking place there. Okay? So, my friends, would you finish for points for tomorrow that 4.1 worksheet? Limits 4.1. You know where I'm at? And I'll put you in for points on that tomorrow. And then again, friends, if you owe me a test or quiz, it's in your best interest to get it made up before we go on spring break. You can certainly make it up after, but you might forget a thing or two if that takes place. Let's see, anyone else come in that I missed? Save.